Hello all, good morning. So today we are going to discuss about the virtual cloud computing for DevOps perspective. So in modern infrastructure, VCC is not just about running virtual machines, it's about building scalable, automated and resilient system. In DevOps, we rely heavily on cloud platforms such as AWS, Azure, or GCP, where virtualization abstracts the underlying hardware. The abstraction allows team to focus on development, automation, and continuous delivery instead of managing physical servers. So VCC enables core DevOps practices such as infrastructure as code, CI/CD pipelines, and auto scaling environments. So instead of thinking of infrastructure as static, we treat it as dynamic and programmable. This shift is what makes modern software delivery fast, reliable, and scalable. Now I am going to show you the second slide that will explain you what is virtual cloud computing. So basically cloud computing is essentially the convergence of virtualization and distributed cloud infrastructure. At a deeper level, cloud providers expose virtualized resources like compute storage and networking through APIs. These APIs allow DevOps engineers to provision infrastructures programmatically using tools like Terraform or CloudFormation. Instead of manually configuring servers, we define infrastructure in code, making deployment reproducible and version controlled. Another important concept here is multi tenancy, where multiple users share the same physical hardware but remain isolated through virtualization. So, VCC is not just resource access, it's about abstracting infrastructure into software defined environments. So now in this slide I'm going to explain the role of virtualization in VCC. This slide shows the hypervisor architecture, which is the backbone of virtualization. There are two main type 1 or bare metal hypervisor like VMware, EXIs run directly on hardware. Type 2 hypervisors like VirtualBox run on top of any operating system. In cloud environments, type 1 hypervisor are used because they offer better performance and isolation. Each virtual machine runs its own operating system and is allocated CPU, memory, and storage virtually. The hypervisor manages scheduling and resource allocation. From a DevOps perspective, we don't directly interact with hypervisor. Instead, cloud platforms abstract this layer. However, understanding this helps in debugging performance issue and optimizing workloads. Also, modern systems are moving towards containerization, which is lighter than VMs, and work at operating system level virtualization. Slide 4. So in this slide, as you can see, this slide represent cloud service models, that is infrastructure as a service, platform as a service, and software as a service. But from a DevOps angle, in infrastructure as a service, we manage virtual machines, networking, and storage. This gives maximum control but also more responsibility. In platform as a service, the platform manages runtime, scaling, and infrastructure, allowing developers to focus on code. In software as a service, everything is managed and users just consume the application. In real world DevOps, we often combine these models. For example, we may use infrastructure as a service for custom backend service, platform as a service for application deployment, and software as a service tools for monitoring and collaboration. Also, modern cloud architecture includes microservices, API gateways, load balancers, and distributed systems, which are critical for scalability and fault tolerance. So in this slide 5, I'm going to tell you about the benefits of VCC. The benefits of VCC go beyond cost saving. First, scalability is achieved through auto scaling groups. where resources automatically adjust based on demand. Second, high availability is ensured through multi-region and multi-zone deployments, reducing single point of failure. Third, DevOps team benefits from automation and CI/CD pipelines where infrastructure and applications are deployed continuously. Another key advantage is resource efficiency as virtualization allows better utilization of hardware. Also, observability tools like monitoring and logging system help maintain system reliability. So overall, VCC enables resilient, scalable and automated infrastructure which is essential for modern applications. Now I am going to tell you the challenges in VCC. Despite its advantages, VCC introduces several challenges, especially at scale. Security is a major concern. Misconfigured cloud resources can expose sensitive data. That's why practices like IAM policies, encryption, and zero trust architecture are critical. Another challenge is cost management. Without proper monitoring, auto scaling can lead to unexpected expenses. There is also complexity in distributed systems where debugging issues across microservices become difficult. Vendor lock in is another issue where applications become tightly coupled to a specific cloud provider. Finally, latency and network dependency can impact performance, especially for global applications. So, DevOps teams must implement strong governance, monitoring, and automation to handle these challenges. Now I am going to conclude my video. So to conclude, virtual cloud computing is the foundation of modern DevOps practices. It enables team to move from traditional infrastructure to cloud native architecture where systems are scalable, automated and resilient. Technologies like container, Kubernetes, serverless computing, and infrastructure as code are all built on top of VCC principles. For anyone working in DevOps, understanding VCC is essential because it directly impacts how applications are built, deployed, and maintained. In the future, we all see even more automation and with AI driven infrastructure and self healing systems. So, VCC is not just a technology, it's a paradigm shift in how we manage and deliver software. Thank you.